Let's move into the Firebase real-time database. Search for the Firebase database package out in pub.dartlang.org and simply install it. We're going to use our last example and just keep building on from that. So we're going to grab pubspec.yaml and add that in. Let's go ahead and do a packages get. Oh, Flutter, you're so funny. Just for giggles, let's do a Flutter upgrade. Which I swear I just did this yesterday, but I digress. And shocker, I still have the same version I had yesterday. But anyways, so packages get, make sure there's no baddies in there, exit code 0, good. So Firebase database with Flutter is now installed. We can go ahead and continue down our path here. Now, if you remember from the previous lesson, we did auth, we did storage, and we've added some buttons in there. And we've got everything running on our emulator. Let's go ahead and run this so we can see what we have and make sure that that dependency installed correctly. It may take just a second for this to build and upload up to the emulator. And there we go. Automatically signs in. We can upload and download information. What we're going to do next is we're going to add a couple buttons here. We're basically just going to build a calculator, increment and decrement. Sounds simple, but the real-time database is actually kind of complex, and that's why I wanted to do a very simple example starting off. So the first thing we absolutely need to do, other than install the package, is actually set it up so that we can run it. So let's get our import in there. And let's say bang bang. Add our import in there. That way we know we're going to use it. Now we need to look at our configuration here, and we need to add an extra line, and this is going to be called database URL. I'm just going to set this to null for the moment, and we're going to move this over just so it looks neat, and we're going to jump actually into Firebase itself. We're going to go into our project, and we want to look at the database. Surprise, we haven't set up the database, so let's go ahead and create one. And we have a few options. We can start locked mode or test mode. Locked mode means you're going to be in production mode, basically. You want to be able to be authenticated, third parties are going to be denied, things like that. Test mode is kind of like a wide open mode. I'm going to start this in locked mode, not test mode. Reason being, I assume most of you that are going to be watching these sets of tutorials are going to want to work in production. You can always set it to test later, but I want to do locked. So right now it's going to create the real-time database, set up our security rules, and make sure everything that we need is right out there. There we go. There's our database. We can add a collection, but we're not going to. There's our rules. And we can build indexes, and we can see usages. Pretty neat how this all works. Now, ironically, even though we just set up the database, we don't have like a little URL here, and we need that for the configuration. Like if we go into storage, you can see there's this nice little URL, but we don't have that for the database. Where did we get this thing from? Let's flip over here, and in our Google Services JSON, it is going to be the Firebase URL right here. So it was set up for us even though we didn't even have to do anything. And it's going to be something at firebase.io.com. Let's go ahead and flip back here. There we go. Now, what we need to do is set up the actual database, the object that we're going to be using. So we're going to say final. Move my keyboard out a little bit here. There we go, final. Firebase database. We'll call this database. Shocking name, I know. And we're going to set up the Firebase database, and first thing it's going to want is the app. Actually, if I remember correctly, that's the only thing we really need is the app. There we go. I'm not 100% certain why that is. I think that Firebase was originally just a real-time database and then they added storage and everything else onto it as it progressed, but I could be 100% wrong. So we're going to add a few things here. We're going to say app, database, storage. Just in case we ever need them, we can just go in and just grab them. And then we can grab our Firebase app. Along with the database. Now we've got references to all of those. And let's actually put that in our state as well. There we go. Now we just need to simply push these through. And we're going to grab them from here and throw them directly into the state. That way, if you are using this as a template and you ever need it, you have references to the app, database, and storage. Even though so far we haven't really had to mess with those too much. All right, so let's play around with our user interface. We're going to grab this and just simply add another row. And we'll say increment and decrement. Nullify those. All right, so now we've got our buttons. Save that, hot reload, checkout. Yep, sure enough. So very simple. We have sign out, sign in, upload, download, increment, decrement. All of this up here works. We're going to get these working really quickly. So in order to do this, we're going to make another file and we're going to call it database. Let's go in here. And I am just going to copy and paste some imports so we don't spend 5 minutes typing them out. Very simply, we just have async, IO, material package, core, database, and animated list, which we're really not using. I got that straight out of the example. We're going to say int counter. We're going to say database reference. We're going to say database error, and we're just going to call this error. So we've already created our database. We've got everything that we need in there. Now, we just need to simply initialize it. But it's not really that simple, as you might have guessed. Not only do we have to initialize it, but we also have to make a reference to a child. You'll see here in just a second. Void init. Let's make this async. And we'll say Firebase database, and we'll call this database. And let's go ahead and say counter ref equal, and we want the Firebase database dot instance dot reference to it, and we want a child. And then we give it a string path. This is very similar to when we were uploading a file. In this case, we're going to say test/counter. Now, one little bit, and we want to counter ref, whoops. One little bit that we want to do is actually keep this synchronized. So we're going to say keep synced, and we want to say true. What that's going to do is act very similar to what you understand as state within a Flutter application, meaning when something changes on the real-time database, it's going to notify all connected clients that that thing has changed. That's actually pretty sweet. That's why it's called a real-time database. So we're going to say database, and we're going to set persistence enabled. And now we want database set persistent cache. And we want this in bytes, and we're just going to give it a very large number. There we go. So our real-time database would be initialized. Let me look at my notes super quick. I'm fairly certain I know exactly where this needs to go, but I want to make sure. Let's test this out just to make sure. Let's do a super.initState, and let's actually just test this out. Oop, we can't do that yet, can we? Because we don't have it actually in here. And let's say import database as Firebase database. All right, just simply want to test out the initialization and see what happens. It may actually crap out on us because, well, you might have guessed, we haven't been authorized yet. So let me see where I'm doing all of this. In the database, I'm going to actually do that. This is asynchronous code, so it's probably not going to work very well. Just want to make sure we don't get any glaring errors. All right, asynchronous suspension. All right. We didn't get any blazing Firebase errors just yet. We just got asynchronous suspension, so that's actually not a bad sign. We got a failed assertion, though. There we go. If we take this out, everything should work. Method not found, huh? Let's just stop that and reload it. There we go. So the code should be working. We haven't really tested that out yet. What we need to do next is we need to add in a counter. And you can see how we're getting notify auth state listeners and things like that. Let's kill that. All right, let's go ahead and let's get our counter. So we're going to say future. And in this case, we want an integer. And I want that. What this is going to do is it's going to actually get a reference to that counter, and then, you guessed it, it's just going to listen to it and say, hey, when something changes, let me know. And it's going to actually go out and get the counter as a hard reference, what it's called, meaning it's going to say, I don't care what's currently changing, I want to read the actual value out of the database. So really we're doing this in two different ways. We're getting the counter and we're listening to it through the database. Sounds really confusing, but that's what a real-time database does, is that you can either get events as they come through subscriptions, or you can read them on your own. We're going to say int value. We're going to await, and we're going to say counter reference. Get back up there. We want to read this one time, so we're going to say once. It's an asynchronous operation. We're going to say then. Don't really need the await and then, but I kind of wanted to make sure we're waiting on it. There we go. And this is going to be a data snapshot. Now, what we're doing with this snapshot is, well, actually pretty simple. We are just going to say print connected to the database. Probably help if I did that in the semicolons. And read. And we're going to get the value of that snapshot. Now, if you're wondering what in the world a snapshot is, it's kind of hard to describe. Let's say you're making changes and 1,000 other people are making changes, and you're all making these changes at the same time. A snapshot is, well, just that. It's a snapshot in time. So this value that we're getting may actually be changing in the background as we're reading it. That's why you need a snapshot. All right, we've got our get counter. Now, let's go ahead and set our counter. to set this to null. And this is going to be a bit more involved. What we're actually doing here is we are pushing the value out to the database. We're going to say transaction result. We're going to grab our counter ref, and we want to run a transaction. In here, we want a mutable data. Mutable data is just simply means data that'll change. And we want this to be async as well. There we go. And then we're just going to say mutable data dot value, and we want to actually have a parameter up here. That's how we're going to set it. And once we're done with that, we're going to say return mutable data. From here, we have to do what's called a transaction. So I should say the transaction is actually running. We need to actually read that transaction. If you've ever done any database programming, you understand what a transaction is. A transaction, in case you don't know, is you make changes. Let's say you make 10 changes, and you want to make sure all 10 of those changes go through. And if any one of them fails, the entire sequence or the entire transaction fails. We're only making one change, but nonetheless, we want to make sure that that actually gets committed to the database. So let's do a transaction result dot committed. Then we can actually say print save the value to the database, else, and let's try to get an error message out of this thing too, just in case. If the error message is not null, then we want to actually print that out. There we go. So really, if you're reading this, we're initializing, we're getting a value, and we're setting a value. It's actually pretty simple, just the code looks a little ugly because it's something we're just not used to. But once you get used to the Firebase patterns of instances and references, it's actually pretty simple the way it works. We've actually honestly worked with much more difficult code in previous sections. So flipping back through my notes here, we need to do a few things. We've got these buttons, and we need to make an increment and a decrement function. So let's go here, and let's say grab that. And we want the counter. And you might have guessed the decrement is very similar. And then we want to actually set the counter when we're done. So we're going to say let's add these functions in here. Now, we need to do a little extra legwork before we can actually do this. We need to actually make an initialized database, because remember, that's the first step here. So we're going to say, actually, let's add it before any of this. And we want this to happen, well, pretty much as soon as the user signs in. So let's go into our sign-in code, and let's look at this. Add that there. Best practice would probably state we shouldn't do that in the set state. We can actually add it here, but we can move it back up if we have issues. All right, so init database. What we're going to do now is we're just simply going to await the Firebase database init, and we're going to give it a reference to our database object. If you can't remember where we got the database object from, remember it's cascading all the way down. We're creating it way up here, and it's going into the stateful widget and then into the actual state itself, and then just coming straight down. Then what we're going to do is we're going to make a subscription. Let's take a look at this a little more in depth. I've got to find my reference for it. I've got a big pile of code I'm staring at here off the screen. There it is. So let's go up here to our state. And we are going to say stream, not Steam. I was thinking of video games for some reason. Steam subscription, there we go. Stream subscription. Event counter subscription. What this allows us to do is actually subscribe to something, subscribe to a stream. A stream is just, think of like a stream, like in your backyard kind of stream with water in it. Information's flowing through, and as that information flows through, we can read specific events. Notice how this is called a counter subscription. So what we're really going to do is subscribe to something. And this is actually pretty cool. Let's go back down into our initialization code. And we're going to say counter subscription equal. We want the database counter ref on value dot listen. And we're going to get an event subscription here. So we're going to grab these. So if you really take a good look at that code, what we're saying here is we're saying in the database, get the counter ref, get the value, or I should say anytime the value is changed, on value is going to be called, and we're going to listen to that event. So anytime on value is triggered inside of Firebase itself, over here in our database, it's going to actually send that subscription notification down in the form of an event. We're going to read that event and do something. And we're going to say set state, and let's do we're going to nullify the error just in case we had a previous one. We're going to get the counter here. The event snapshot value, remember what a snapshot is? It's just a snapshot in time. And if it's just null, we're going to say 0. So essentially what we're doing here is pretty simple. We're just subscribing to an event. When that event happens, we're setting our internal state. But the data is actually out on Firebase. And that's what I meant earlier in these tutorials, how you really have two sets of state here. You have your local and your remote off in the cloud. So what we're doing here is we're updating our local state. All right, so we've got that. Now Let's grab this guy. And we're going to say on error. Object O. So if we have some type of error, we want to actually figure out what the heck's going on here. And we're going to say final. We want data. Let's call this database error. And then we're going to set our state. That way we can see something is going on, something's happening here. Now, how do we actually print that on the screen here? Well, let's do this. Let's grab this guy and let's expand our user interface out just a bit. So now what we're going to do is we're going to say going to grab our Firebase database counter, and we'll say error. And we want to do that as a toString, or we'll get some sort of big fat, you know what kind of error message. Let's run this, see what we got. It may take just a second for this to compile and run. While it's compiling and running, we can see our database is pretty much blank. There's nothing in there. All right, so we've got signed in, counter, error 0. Let's increment this. You can see how our counter increments. Let's increment that a few times. We're getting no errors, so that's good. You can see save value to database. And we can decrement too. Let's look at Firebase itself and see what's going on here. We may have to click off somewhere else, and boom, we've got our real-time database along with the cloud store. There's a difference between these two, and it's kind of subtle but very important. The real-time database is for real-time changes. The cloud Firestore is, well, it's just a database. And I don't want to say just a database because it has its own set of rules and indexes. Now, the real-time database also has its own set of rules and indexes. And you can see there's our counter. So let's pull up our emulator right next to this, and you can see in real time what's changing. Let's pull this app up, and let's pull in the database here. And instead of tests, let's call this my app. Do a hot reload. Actually, let's just rerun the whole thing from scratch here. Get our Firebase up, we got our emulator, we're signed in, our counter 0. Counter 0 because we changed the reference. It's no longer reading this, it's reading my app counter, which doesn't exist, but when we increment, you see how boom, it suddenly creates it. That's why this is a real-time database. What's happening is we are making a value, shooting it out to the database is changing, triggering the on value change, and notifying our application through that stream subscription. Pretty neat.